1.2 is still talking about graphs and how to interpret graphs, but it's going to go on to an idea of functions as well. So the first thing we want to talk about when we're talking about graphing in this section is this idea of domain and range. So understanding what the possible x values are for a graph, which is your domain, which can also be called your inputs on the horizontal axis, and your range, which is your possible y values or outputs for your graph. So if you look at an example like this is a radical graph, right? Because it's got this half parabola shape on its side. And we're saying, well, what are the possible x values for this? So when you look at it, you're like, well, where do they start? Well, they start at -4, and then they keep going all the way to the right. So your domain is anything greater than or equal to -4. This is called interval notation. If you are not comfortable with interval notation, please feel free to go to the just-in-time 6 on page 867 now and just review this notation. Now, if you're like, I don't even like interval notation, I want to answer everything in set notation, that's cool too. So this domain could be x is greater than or equal to -4. If none of that makes sense to you and you do the just-in-time, please contact me and I can help you out. So this one has got the range as well. So the range is the possible y values. And so if you look at this graph, the first y value is here. There's nothing below the graph. So this is a point -4, 0. And so the first y value of this graph, or the lowest y value, is down here at 0, and then they go all the way up. And so from 0 to infinity, or y is anything greater than or equal to 0 if you're into set notation. All right, so let's find domain and range. So domain and range is a very specific skill that people love or they hate. And if you hate it, we just have to find a way to make you love it. It's just a very visual thing. This is something that I love to do with people because then I can see sort of where you're getting lost or what you're not seeing. But I'm just going to go through these and hope that it makes sense to you. And then you're going to go and do the quick check on page 30, and then we're going to make sure that you're okay with domain and range. And if not, come and see me. All right, or someone who can help you. Let's start with domain. So domain is the possible x values for a graph. So if you look at this graph, there are no points to the left of -1. So my x values are going to start here at 1. Then I can see that this graph casts a shadow. There's x values all the way until we get to 5. So my domain in interval notation would be anything between 1 and 5 inclusive. So square brackets means that it can be equal to those numbers. Round brackets means it cannot be equal to. If you do not like interval notation, I love set notation as well, and it's a bit more descriptive. It says that x is anything greater than or equal to 1 and less than or equal to 5. Then we move on to the range. So your range is your possible y values. So if the x values we're looking where it casts a shadow onto the x-axis, then the y values, or the range, we're looking at where it casts a shadow onto the y-axis. So if we look, it starts here at 1, and then it hits all the way along until you hit here. This is the highest point of your graph, up here at 4. So your range is going to be anything between 1 and 4 in interval notation, or anything between 1 and 4 in set notation. Okay, so I just ran and checked my textbook again because this is a new textbook to me, and I just wanted to see, like, is the textbook have a preference of one or the other? The textbook loves interval notation. So after this example, I'm going to stop writing set notation to try to get you comfortable with interval notation. But on a test, if you gave me set notation, I would give you 100%. But I want to be consistent with this textbook, so I'm going to stop writing both and I'm going to stick with interval notation. Okay, so let's look at this next graph. We're doing domain. I'm going to switch to blue. So domain, again, is all your possible x values. Now, a trigger for me is a big difference between this graph and this graph is that this graph has arrows and this graph had dots. This graph I knew would have a discrete start and end point, whereas this one, because of these arrows, it's keeping on going on the left. So if I were to keep that going on the x-axis, it goes this way. And then if I look at all the points going this way, they don't stop that way either. Now, technically, this is just a small representation of what the graph would look like, right? These axes would continue on. In fact, there'd be a negative y and a negative x portion as well. So if you think about where they go to, well, they're going all the way up to positive infinity, and then they're going to go all the way this way, even though the graph isn't showing it, down to negative infinity. So the domain of this graph is anything from negative infinity up to positive infinity, which means that x can be an element of the real number systems. X can be, sorry, I can't stop saying set notation. I love set notation. Interval notation. It's anything from negative infinity to infinity, which means it can be anything. Now, infinities will always have round brackets because you can't be equal to something that you don't know really what it is. Okay, and then we look at the range. So when we switch to the range, we're looking at, are there arrows going down and are there arrows going up? And for this graph, there isn't. The arrows only go left and right. They don't go up and down. So there's going to be a discrete start and stop point for this graph in the range. And so it starts here at 1. There's no graph below this. And then it's traveling all the way up. And then this would be my highest y value here at 5. So it's going up from 1 to 5 inclusive. And my range would be 1 to 5 inclusive, meaning equal to 1, equal to 5. All right. Let's look at this graph. Again, I'm noticing the difference between the third graph and the fourth graph. This graph has dots. This graph has arrows. One of them is going to keep going. One of them is going to have a discrete start and end point. So if we look at this one, this is the one that has discrete start and stop. So this one starts at 1 and it ends at 5. So the domain would be negative, or sorry, not negative, 1 to 5. The range is starting here at 1, there's nothing below, and it's stopping here at 5. So the range is also 1 to 5. Okay, let's move on to this guy. This guy has arrows, so it's going to be different than the graph we just did because it keeps on going. Now these arrows both reach up, but they're reaching up and out. So if I look at this point, sometimes I like to look at these ones as kind of starting here. The x values continue and they keep going because the arrow goes. These x values go along and they keep going because of the arrows. So the domain is again going to be negative infinity up to infinity. The range, however, the arrows only point up. So there's going to be a starting point. So there is no y value below here. So my graph is going to start at 2, but then it can go up forever. So the range of this graph would be 2 all the way up to infinity. All right, now this is going to start making us think about something that's coming up. This is part of a graph. So this next example, you'll see this one even gave an equation. This is a graph of y equals x squared minus 1, but I'm only showing x values between negative 2 and 1. So this is part of this graph. So this one actually kind of gave you the domain, right? The x values go between negative 2 and 1. Now all of a sudden we have these open circles we've never seen before. Every other graph we looked at that had dots, they were closed in dots, which means those points existed. If you have an open dot, it means that those points, they go up to there, but not actually to there. So the difference is instead of using square brackets, we would say this graph goes from negative 2 to 1 with round brackets. So this one's domain is negative 2 to 1 round brackets. Then we look at the range. The range, you're looking at the bottom point up to the top point. So this one is a bit tricky. So this point here is not open. So this is included. This would be a square bracket, whereas the top point here is open. So this one would actually be a round bracket. So this range is going to go from negative 1 up to 2, not inclusive. Okay, so square bracket negative 1 all the way up to 2. In other words, y can be greater than or equal to negative 1, but less than 2. All right, moving on to these last graph. Maybe you've stopped listening to me, maybe you've started doing them, which is great, and you're just checking these for answers. This is, again, something that you might not know coming up. So this is another one that's done in pieces. This is one piece of the graph defined by an equation, and this is another piece. And we're going to be learning how to do this as the course progresses, or as this chapter progresses, I should say. But for now, we're just looking at domain and range. So from a domain perspective, I can see this arrow going over. So I'm like, okay, there's something to be said about the graph having x values from -1 over, but not including -1, right, for this section. But then I can see that there is actually a closed circle at -1. So this point actually does exist. In fact, this point exists, and then the graph has x values all the way along this way as well. This one has a domain of -infinity up to infinity. Okay, let's look at the range. The range of this odd graph is the bottom part is -3. This is where it's going to start. So I have y values all the way along. So even though that dot's here, we still have y values over here. Here we have a ton of y values, okay, but we keep going. And we've got this arrow up and we follow it. So the range of this graph is going to be -3 up to infinity. So like I was saying when we started this, domain and range is something you either hate or love, so you got to go practice it. And if this is just not seeming right, book some time with me. Go into your local center and ask for help in person, but get this sorted. Domain and range is actually a really important skill. So quick check, page 30, numbers 65 to 72.